Hello everyone, welcome back to this channel, and today in this video I'm gonna teach you how you can compute for the displacement. Alright, so when we say displacement, this has something to do and related to motion. So to fully describe the motion of an object, we need the concept of displacement. So displacement is defined as a directed distance from the initial to final position. Alright, so this is also known to be a vector quantity, and it means that the vector quantity, it must have a magnitude and a direction. Okay, so that is how we basically define displacement. So for example, I have a certain fly, right? So that is flying around. Okay, and then it end up somewhere here. Okay, so this is the initial position of the fly, and then this is the final. Okay, so this is the path covered or traveled, and this is the total distance traveled. So that's distance. Okay, so however, when we say displacement, it's just the initial and final position. So this one, I think I should use this one. That matters the most. Okay, so that is the what you call the directed distance, and this thing right here that joins point A and point B, or initial and final position, is what you call the displacement. So you will see the big difference between distance and displacement. So distance is the total, it's the length of the path that is traveled or covered, while displacement is just the distance from the initial to final position. So they are really different from one another. Alright, so to understand it better, I think I should draw um, a rectangle, so a rectangular court that has a measure of a length of 74 feet. Alright, so I think I can make it 74 feet, and this will be the length, and then 30 feet would be the width. Alright, so I can name it, I can name the corners as points. So I can name it as point A, then this is point B, yep, and then this is point C, and then this is point D. Okay, so if you are to run around from point A going to point B, so you will travel a certain distance of 74 feet. Alright, so let's say for example you run from point A. Okay, let's say this one. You run from point A and you reach point B. You did not stop there, and you reach point C. So you reach this point. So my question now is, what is the distance traveled? Distance. Alright. So to find the distance, you have to add the length of the line segment. Okay, you write D for distance is equivalent to line AB, length of line A to B. So there you go. The line over A and B indicates that it is a line segment, plus length of line BC. Okay, and that's 74 feet. plus 30 feet, and that would be 104 feet. Alright, so the distance you have covered is 104 feet. Alright, so how about the displacement from point A to point C? So we draw again the court and give it the same dimension. Alright, so there it is. So this is A, or point A, point B, then point C. So we know that this is 74 feet and this is 30 feet. And then we have defined displacement as the directed distance from the initial to final position, and you know that it must be a straight line, so I'm gonna make a straight line from A to C. Okay, so this one is actually the missing part. Okay, we need the distance from A to C because that is the directed distance and it is our displacement. Alright, so you will notice that there is no direct calculation for this rather than or other than making use of the Pythagorean theorem. So after you have noticed that we have a right angle somewhere here, and this is actually a right triangle, and this one is the hypotenuse. Alright, hypo for hypotenuse. Alright, and then we have the legs of the triangle, which are 74 feet and 30 feet. So we can execute the Pythagorean theorem, stating that the sum of the squares of the right triangle equals the sum of the squares of the hypotenuse. So a squared plus b squared is equivalent to c squared. Alright, so c squared there is our hypotenuse, and it is also the displacement from point A to point C. So we're looking for c squared. Alright, so um, A can be any of the legs of the triangle. So we can use AB for that. So we can substitute AB. So I'm gonna use green. Alright, so AB, and then we can make it like this, squared plus BC. Alright, and then we can square it, and then that is equivalent to line AC, length of line AC to the power of 2. And then we have to substitute the value of AB, which is 74 feet. Alright, and then square that, plus 30 feet, then you have to square that, and that is equal to line AC raised to the power of 2. Okay, so when you square this, it's 5476 square foot, alright, or feet squared, plus 900. Okay, 900, and then that's equivalent to this one. Okay, so if you want to check, you can get your calculator, and then we can check. So if you bring in your calculator, it's in here. So that's 74 to the power of 2, or 74 times 74, that's 5476, and 90 times 90 is 30 times 30, okay, is 900. Alright, so you add them together and you get 6376. Okay, so you get 6376, and then still naka feet squared, and then you get the square root of this. So you get the square root to get AC. So we have to get the square root, and then I'm gonna uh, bring in another color to emphasize that we're taking the square root of both sides. So there we go, it will cancel out, and you will get around other colors. Yeah, so 79 point something. Okay, point something, and it can be round off to 80. All right, so let's get the calculator and get the square root of that. Okay, 79.8 feet, or to be exact, the length of this is yeah, so 79.8 feet, but we can round it off to 80. Okay, so let's say that the hypotenuse is equivalent to 80 feet, and this is actually our displacement from point A to point C. Yeah, there we go. This is our displacement. So without the Pythagorean theorem, computing the displacement would be difficult for any shape, okay, or for any path. Okay, so you need to know how to do it. All right, so as we have said, displacement is a vector quantity, so therefore it must have a direction from the initial position. And we know that in a triangle, there are angles involved, and these angles are the one that tells us that can help us to tell the direction. All right, so here we have an angle theta here, which tells us the direction. All right, or can help us to tell the direction. So we are going to find the angle still using some basic knowledge of trigonometry. Okay, and then I have to draw the triangle again inside our rectangle. So I have point A, point B, point C, and then D, and then we are going to supply the values. All right, and now we are looking for theta, or the angle here. So the values are 74 feet for length of line AB, 30 feet for line AC, and then 80 feet for line AC. Alright, and right now I know how teach you how you can solve for the angle using the trigonometric function known as the sine function. Sine theta, or sine of the angle theta, is the relationship between the opposite side over the hypotenuse. Alright? So in our figure, the opposite side is the side farthest away from the angle. So the side farthest away from the angle is 30 feet, or that's line BC, side BC. So that's gonna be side BC, alright, or length of side BC all over the hypotenuse. The hypotenuse is the longest side and always opposite the right angle over here. So that's gonna be AC. So when you do it, when you substitute it, so you're gonna have sine theta is equivalent to length of line BC is 30 feet all over 80 feet. Okay, so this will be unitless because the feet will be equal to 1, will cancel out because foot divided by foot is just 1, and 30 times 1 is 1, and 80 times 1 is 1. So right now, this is uh, the value of the sine of the angle. So to get theta, so you get sine theta, or you type sine theta in your calculator, or arc sine theta, you raise it to the negative 1. Okay? And then that's gonna be 30 all over 80. And then you can see that. Let's bring in the calculator. Okay. So you first divide 30 all over 80, and then you click trigonometry, second function, sine. Alright, so theta here is equivalent to 22.0, no, that's the angle, that's the degree, 02 degrees. So that's it. That's how we get the value of the angle. But we are not done yet. We just um, we just get the value of the angle. Okay. We're not done yet with telling the direction. Okay. So basically, people knows north, east, south, and west. Okay. So we're going to translate this information into an information that humans can understand. Alright, so I now redraw this um, rectangle, rectangular court I mean, and I think we can extend some lines. Alright, there we go. Okay, so change colors. Oh no. Alright, maybe. I'll just stay with the red ones. Yeah, the red one's good. And then write the north. Where's the north? So customarily it's assigned right here, and then this is your east, your south, and then your west. All right, so we now draw the triangle, and we know that this is point A, which is the origin. Okay, this is point B, and then you go to point C, and we're able to know the angle right here, and that's equivalent to 22.02 degrees. Okay, so how to translate this into direction? You just have to add. Why you have to add? Because this one here is a 90-degree. Okay, we are now getting the bearing. So 90 degrees plus this one. So you have to add this, add that angle over there. So you have to add it plus 22.02 degrees, and that's gonna be 112.02 degrees, and that's going eastward, okay, from north. Okay, so this information is what we call the bearing. So this is the bearing. Okay, there we go. So you have 112 degrees. You move 112 degrees east of north. Okay, so that's how uh, bearing is used, or trigonometry is used to tell the bearing, and that is how trigonometry is used to find the displacement. Okay, so we see that physics is interconnected to mathematics, and especially to the branch of trigonometry. So I hope you guys learned something from this humble lecture of mine. See you other times here in the university.